Here we're trying to solve an equation involving rational expressions. So the first thing we want to do is factor all denominators. The only one that's factorable is the last one. It's a trinomial. Leading coefficient is 1. The last term is positive. So signs match the middle. And 2 times 3 is 6, and they add up to 5. So now we need our LCD. And from the first denominator, we know x plus 2 has to be a factor. From the second denominator, we know x plus 3 has to be a factor. Looking at the third denominator, x plus 2 is already there. X plus 3 is already there. So that's our LCD. So now we're going to multiply every term by the LCD. So we have x plus 2 times x plus 3. And I'm going to put it over 1 because I'm multiplying by a fraction. Minus, and always beware the minus, okay? We'll come back to that. And again, x plus 2 times x plus 3, our LCD. And we'll put it over 1 because we're multiplying by 3 over x plus 3. And I'm going to run out of room on my screen, so I'm going to go to the next line. Equals x plus 2 times x plus 3 over 1 times 6 over x plus 2 times x plus 3. Okay, so looking at this first term, we can see x plus 2 in this numerator as a factor and x plus 2 in this denominator. So we cancel and we're left with 4 times x plus 3. So that's 4x plus 12. In this next term, we have a common factor of x plus 3. We cancel and we're left with 3 times x plus 2. And I'm going to write this out, minus 3 times x plus 2. Because we have to be very careful with this negative, or this minus. Equals, and in this last term here, x plus 2 is in the numerator here and the denominator here. X plus 3 is in the numerator here and the denominator here. And of course we wind up with 1s. And we're left with 6 over 1. So we have 4x plus 12 minus 3x minus 6 equals 6. Let's clean up the left side. 4x minus 3x is just 1x. 12 minus 6 is just 6. Now we have to evaluate the type of equation we have. There is no x squared this time. In fact, this is a linear equation. So all we have to do is isolate the variable. And we're left with x on the left and just 0 on the right. X equals 0. Is that okay? Because we need to check the solution. Let's go back to the original equation. If we put 0 in for x, this denominator will be 2. That's fine. If we put 0 in for x here, this denominator will be 3, and that's fine. If we put 0 in for x here, we get 0 plus 0 plus 6, so this denominator will just be 6. Or we could have tested it in the LCD. The 0 might make either factor equal to 0, and it doesn't. So we do get one solution, and that solution is 0. So when x equals 0, this expression minus this expression does equal that expression.